Okay, so let me look at our schedule here. So we have, today is the 8th. So we're actually right on schedule. We're supposed to start graphing quadratics today. And then the 21st of this month, which is, okay, so not this week, but next week on Friday is the official drop date for all classes that are 16-week spring classes. So if you're taking any other classes that are 16 weeks long, the drop date is next Friday, which means if you don't want to take the letter grade that you have in the class, then you want to drop the class and take a W. And the W will not impact your GPA as much. It still will impact your GPA, but it won't be as much as an F or a D would be. All right? So everyone aware of that? Okay. To withdraw from a class, I believe you can just go online and submit a request, and then I get a request, and then I just click and you're dropped from the class. So I'm not telling you go drop the class. I'm just saying be aware of the drop date, okay? Because once the drop date passes, there's nothing that can be done. All right, you have to take the letter grade, whatever it is. All right, well, most of that test you just took was about factoring and solving quadratic equations, right? And the purpose for doing that is so that we could do this. So you still need to be able to factor, you still need to be able to solve quadratic equations. Those two things are going to be at play here. But now we're going to use those techniques within a bigger problem. So do you remember when we threw that thing around the room? Okay, we were talking about if you take a quadratic function. So notice the way we have that written. Instead of writing y equals ax squared plus bx plus c, right? So compare that to this. Do we all know what this is when we graph it? What is that? That's a line, okay? Y equals mx plus b is a line. So what we're going to look at now is y equals ax squared plus bx plus c. This right here is what we call a parabola. Now, this y, you can just replace it with f of x. And it's just a different notation. All it says is that this is a function of x, but it's the same as y. So I want you to just look at that notation f of x as being y, all right? So when we see here quadratic functions in the expanded form f of x equals ax squared plus bx plus c, we are talking about quadratics, which when we graph them, we say look like parabolas. And this is what they're going to look like right here. You're going to have, whenever we have a quadratic function like this, it's either going to look like this or it's going to look like that. So this was the one where I threw the ball, right? Or what did we throw? A marker? We threw it through the air, right? That parabola, we would say that parabola opens down, okay? And then this parabola over here opens up. But this is the shape, all right? You're all probably familiar with this. You probably have seen this in the past. So since it's going to be either up or down, we need to see if there's an easy way to determine which one it's going to be. And it turns out there is. There's a very easy way to tell. Does anyone know? I'm sure some of you know. No? If what's positive? Yeah, so you remember when we're solving quadratic equations, we would identify A, B, and C, right, and use them in the quadratic formula? Well, the way you determine whether or not a parabola is going to open up or down is by looking at that A, just the A. So let me move this up a little bit. We'll try that again. That didn't work. Where's my? There it is. Okay, so let's look at that. Let's look at that A right here. Okay, if that A is positive, greater than 0, it's going to open up. All right. And if the A is negative, it will open down, less than 0. So it's a very quick check. When you look at a quadratic function, it's a very quick check to see whether or not it opens up or down. Do you all agree with that? You just look at a number, and if it's positive, it opens up. If it's negative, it opens down. I like to just remember, like, you know, positive people, happy people, right? People are positive, they're happy, so they smile. It's like a smile. This is more like a frown, right? Negative people are all like, ugh. Okay. So we have an easy check for that. Now we have this thing called the axis of symmetry. The axis of symmetry. So in a parabola, when you draw it, if you imagine a dotted line going right down the middle of the parabola like this, or here it would go down right here. That is a vertical line, isn't it? It's not part of the graph. Okay, the graph is the parabola. But imagine that there's this dotted imaginary line right there. We call that the axis of symmetry. All right? And the reason it's called that is because if you were to take, let's say, the right side of this and reflect it over that line, it would land right on the other side. So it's a mirror image of itself over that line. It's symmetric. So we call that the axis of symmetry. And there's an easy way to find what that line is. And I don't think anyone here knows what it is. Yeah? No? Like some people knew positive opens up, negative down. Anyone know how you can find that dotted line? No? It's okay. So it is, you have to do a calculation. You have to calculate negative b divided by 2 times a. So remember how you're gonna know what a, b, and c are, right? If you take whatever b is, change the sign, and then divide it by 2 times the a, then that will give you where that dotted line lies. And we're going to do examples of this, all right? I'm just giving you the formulas and the things we need before we do it. Okay, we good? All right, now there's another important part of a parabola that we need to know, and that is this point right here and this point right here. So those 2 points right there have a very special meaning to us. This point would be the lowest point on the graph, wouldn't it? That'd be your lowest point. And then this point right there would be the highest point on the graph, which when we're throwing a marker back and forth in the room, the highest point would be that point we're talking about there, right? So that point is called the vertex. And, you know, over here it's called the same thing. It's called the vertex of the parabola. And do you agree that that is a point, right? It's not a line or anything else, just a point. And since it's a point, it should have an x and a y coordinate, shouldn't it? Like it should have some x and y coordinate. Well, we have a formula to get that x and y coordinate. And the formula is as follows. First of all, since it's a point, I should call it like xy, right? But we don't. We actually call it something else. We call it hk. All right, so that's an x coordinate and that's a y coordinate. I know, like, why not use x and y? It's because it's a special point. It's not just any point on the parabola. It's the vertex. And because it's the vertex, we use the letters h and k to represent it. All right? So how do we actually find those? Well, h, to find out what h is, you have to do this calculation. Wait a minute. Does that look familiar? Isn't that the same thing as the line, this line of symmetry? And it should be, because doesn't this point, isn't the x coordinate the same as where the dotted line is? Right? So that's why this h will always be that calculation. All right? And then to get k is the tricky one. What we do is we take this answer and we plug it into the function. So it's f of negative b over 2a. I know that looks complicated, but once we do it, you'll see this is not that bad, all right? Just write this down for now. This is what we refer to as the vertex formula, all right? Okay, are we okay up to this? Because I'm going to erase some of this. Yes? Okay, I want you to go back and I want you to see if you can remember something. When we were graphing lines, before we did this, we did lines way back. When we graph a line like this, do you remember? That's not a very good picture. Let me do it this way. What was this point right there called on a line? The X-intercept. And what was this point called? The Y-intercept. Oh, remember that? Do you remember how it is that you find the X-intercept for a line? Set what to 0? You set y to 0 to find out when x, what x would, yeah. You set y to 0 and you solve for x. That's what we would do, right? Okay, so that's what we did. And then how do we find the y-intercept? Set x to 0 and figure out what y is, right? We're going to do the exact same thing here. When you are looking at this, y equals ax squared plus bx plus c. Okay, this is a major thing right now. Okay, let's see if you can follow this. It's not difficult, it's just important. We would like to know where those 2 points are. Those are x-intercepts, right? We have an x-intercept here, and we have another x-intercept here. We actually have 2 in this picture, don't we? And over here we have 2 also. So how can we find those x-intercepts? Well, we do it exactly the same way as we did it with lines. To find the x-intercept, you set what to 0? Y to 0. So if you are given a quadratic like this and you want to find the x-intercepts, then what you're going to do is set y to 0 and solve for x. So look what happens. If I replace y with 0, what does this become? That becomes a quadratic equation, and that's what you just took a test on, isn't it? You just had a test on how to solve these, didn't you? Now do you see that within this problem, if I give you a parabola to start, I'm going to ask you to give me, I'm going to ask you, does it open up or down? I'm going to ask you, where's the line of symmetry? I'm going to ask you, where's the vertex? I'm going to ask you where its x-intercepts are. When you go to find the x-intercepts, you're going to go back and do what you just did on exam 3. Okay? So this is just one part of a bigger problem now. Do y'all see that? So this you'd have to solve. However you solve it, you're either going to factor that or you're going to use your quadratic formula, whatever works better for you. Okay? Now, how would we find the y-intercepts? Set x to 0. But watch what happens when you set x to 0. Set x to 0, solve for y. This is actually pretty nice what's about to happen. If I set x equal to 0 here, what happens? If that's 0, that's gone. If that's 0, that's gone. And all you get is what? Y is equal to c. And so this number right here is always your y-intercept. You actually don't have to do any work. It's kind of like when we had y equals mx plus b. Remember when we were doing that with lines? This number right here was your y-intercept, and that was the slope of your line. Well, with quadratics, as long as they're written like this, that number out here by itself is going to be your y-intercept, always. That kind of makes sense? Okay. All right, what else? I think that's it for now. I think we can get to an example, but I do want to, before we do one, I want to talk about solving this equation. When we solve this equation right here, when we get to this point, you might use that formula right? You might use that formula, quadratic formula. What happens when everything underneath this radical is a negative number? What did we say when we were solving these and this was negative under here? Said what? No solution. No real solution. So what do you think our parabola would have to look like for us to not have x-intercepts? It doesn't cross the x-axis. So do you think it's possible to draw a parabola that would do that? I mean, that's a parabola, right? Does it hit the x-axis? No, it doesn't, does it? So if you were to go through the work for this, when you get to the point of trying to find the x-intercepts, I guarantee you that that parabola, you would get a negative under here. Guaranteed. All right? Now, what if your parabola did this? Well, then you're going to have 2, right? And that would be kind of like you were getting on the test. You were getting two different answers, right? Those two different answers now represent these two numbers, these two x coordinates. So it looks like in this case you could have no solution. In this case you would have two solutions. Is it possible to have only one? How? What would the parabola have to look like? Just touching. So that means just the vertex touches, right? That could happen. That could happen where you have just one x-intercept. Now, I'll tell you when that's going to happen here. If this under here turns out to be a 0. Imagine that this whole thing is 0, right? Then do you agree that everything's gone? Like all of this is gone? And what are you left with? This is kind of crazy, but look at what are you left with if all that's gone? The vertex formula, right? Negative b over 2a, which is what it should be, right? Because that point right there, the x coordinate is negative b over 2a. So all I'm trying to say to you is this. If we kind of know, like ahead of time, let's say somehow ahead of time, I knew that my parabola looked like this. Would you go try and solve a quadratic formula if you knew that? No, right? You're wasting your time, aren't you? If you knew it looked like this, would you go use your quadratic formula? Yes. If you knew it did this, would you go use your quadratic formula? No, because you have the vertex already, right? Does that make sense? So we are going, when we go to graph these things, we're going to use that logic. And we're going to work through a couple of examples. So you'll hopefully get comfortable with this, all right? So let's get started. The whole goal here today is to be able to graph a quadratic function and then get all that information. Does this seem exciting? No? You know? Okay. So let's start with this one right here. I'm going to write it down on the board, and then I'm going to just do it on a blank page. I'm going to take all this stuff off. All right. So I've been teaching for a long time, right? I've told you that already. And I always graph quadratic functions. The way I teach it, I think, is different than anywhere I've ever seen in a book. There's just one little slight thing I do differently. So I'm just letting you know that, because if you go to the tutoring lab and you're asking for help or something, I'm pretty sure they're not going to do it this way. So I'm just giving you forewarning. And I'll tell you, when I get to the step that I do differently, I will tell you. All right? You ready? There we go. So the instructions are to, I'm going to put sketch this quadratic. Or if you don't like that, we'll call it a parabola. Include, what do I want? Does it open up or down? So I want you to tell me if it opens up or down. I want to know what the vertex is. I want to know the X-Intercepts. I want to know the Y-Intercepts. And then I want to sketch, okay? So I want you to be able to give me all this information. Does it open up or down? I want you to tell me the vertex, X-Intercept, Y-Intercept, and sketch. Now the axis of symmetry, let's throw that in here, right? I really don't care too much about the axis of symmetry personally, but it's going to be in your homework, so go ahead and do it. The reason I don't care about the axis of symmetry is because once you have the vertex, you have the axis of symmetry. You know where that point is, so it's kind of redundant. We're doing it twice. All right, you ready? So, first step. Here's the procedure that I'd like you to use. So, steps are this. First, we're going to determine, does it open up or down? Let's go through the steps first before we do the example. Okay, this is what we need to get, but this is the actual procedure we're going to do. Okay, so does it open up or down? Second step, we're going to find the vertex. All right. Here's the step that I do that's different. All right. This is the step right here. Step 3, we're going to do what I'm calling a quick sketch. Okay, we're going to do a quick sketch. We're actually going to draw it. After we know these two things, we're going to do a quick little drawing of what we have. And then from that, you should know whether or not you have X-intercepts or not. All right? So the fourth step is get the X-intercepts, okay, only if you have them. All right? Only if you have them. And then the fifth step, you're going to get the Y-intercept. And then the sixth step, you're going to sketch it. So I know that looks exactly pretty much like that list over there. But this quick sketch is the part that's different. So let's go through the procedure. Okay, first step. Let's see if I have my little sticks in here. I thought I did. I guess not. Okay. So what's first then? What do you have? Okay, so what does it do? Okay, opens down. So here's the deal. Let's do this since I don't have my sticks. If you answer me, you're out, okay? So you can't answer again. All right, so I heard you, all right? So you're out. So it opens down. Why does it open down?
Because it's less than 1.
What's less than 1? A. So what's A in the problem?
Negative 2.
-2. So A is -2. Everyone have that? That's -2. And that is less than 0 because it's a negative number. Because less than 0, we know it opens down. So you already know your parabola looks like that, right? Okay. Now, second step is to find the vertex. So who wants to tell me how I'm going to find H and K? Okay, so you're finding H first, right? Okay, so we want to calculate H. You said that's -b over 2a. You want to keep going? What is -b? Okay, so we take that number and take the opposite of it. Very much like we did when we were doing the quadratic formula. Remember how it was always like the opposite of this? Same thing. So if that's +4, this is going to be -4 over 2 times what? So what's A? What's that? -2. Okay, everyone got that? So maybe before we started, we should have just listed out here what A, B, and C were. A was -2. B was 4, and C is 1, right? So that's -b over 2 times A. What's next? We have to figure out what that number is, right? So who's up next? Who's going to tell me what that number is? Who's that? It's 1? Okay. So everyone's going to respond today at some point, hopefully. So H is 1. All right, who wants to go next? What do I do next?
Okay.
Find K, right? Good. So how do I find K?
You plug the answer for H.
Okay. Yes, right. We plug this in to that. Okay, so here's how this works. What I want to do is I want to take that function up there, and I want to plug 1 in. Okay, so I'm plugging 1, this answer, into that. And that means I just rewrite this and replace every x I see with 1. Okay, so what's this going to look like? -2, right? Then I'm going to replace that x with 1 and then square it. Then +4, and then I replace that x with 1 and then +1. Okay? Who's up next? Who wants to tell me what that calculates to be? 9? Do you all agree? 7?
Wait.
So this squared, is this squared acting on that too, -2? It is not. It's only squaring the 1, okay? So you square the 1 first, you get 1. Then you multiply it times -2. So that gives you -2, right? 4 times 1 gives you 4, so we're adding 4, and then we're adding 1. So what do you get? 3. Okay, so 3. We all good? So this vertex, remember we said the vertex was a point, wasn't it? That vertex, we found the point. The point is 1, 3. Has an x-coordinate of 1 and a y-coordinate of 3. What is the next step in the procedure? A quick sketch. And when I say quick sketch, I mean really quick sketch. Don't be sitting there, don't get your ruler out and start. I mean, this is going to be super fast. Ready? So watch how this goes. I want to leave my steps up, so I'm going to erase this. Is that all right? Okay, so here comes my quick sketch. Okay, where's my vertex? At 1, 3. 1, so watch, I'm just going to go 1, 1, 2, 3. Close enough, right? That's to the right 1, up 3. Close enough? Which way does my parabola open? Down. So if it opens down, it has to do this, doesn't it? So how many x-intercepts am I going to have? 2. So that means I do want to go through and find x-intercepts now. Do you see how that helps you? Like if this opened up, right? Had this opened up, what would we have done? We would have skipped step 4. And we would have gone straight to step 5. Does that make sense? Okay. That just saves you time. If you don't want to do that, then go ahead and work through the quadratic formula and get negatives underneath the root and then say no solutions and then go to step 5. But you're wasting time. All right? So step 4 now is what's up next. So I'm going to put here, we should have 2 x-intercepts. So I'm going to move on to step 4. So for step 4, finding the x-intercepts, who's up? Solve it. Okay, so we solve for x, which means we go back up to the thing and just basically set it equal to 0. Yep. So we take this and set it equal to 0. And now we're back in the previous exam, right? We're taking the exam. Oh, hey, I didn't mention. Thank you for being here on time. I appreciate that. No, I do. I do. I'll go off the record here. All right, back to business. How are we going to solve this? Am I out of line to ask that of her? Okay. It's tough being a step parent, man. So her dad doesn't care. Let her wear what she wants to wear. Okay. Yeah, exactly. Well, he's her best friend. That doesn't work for your whole life, you know. -2 times 1, right? -2 and then 4, like this. I'm trying this first. I'm trying to factor, but don't think it's going to work, right? I'm not going to be able to come up with 2 numbers, multiply to be this, and add up to be this. So I'm nothing left but the quadratic formula. And I know I'm going to get answers. Like, I know they're going to come, right? When I do that square root thing, I'm going to get answers. The picture told me I have to. So now I have to do that. So here we go. You're not a girl. You're not a girl. You don't understand. But I'm a guy, so I know what girls like that, you know? It's like, you know, no? You dress like that, it's like, you know, you're presenting yourself a certain way.
I have a daughter, you know, when I was younger, I dressed that way.
Yeah.
I have a daughter, and I'm like, no, just go back up. You know, I'm going to get it.
Yeah. And you know what? I've told her, I said, you know what? It's not even about, like, you listen to me. It's just, as a parent, it's my duty to do that. Like, we're gonna disagree. Yeah, so. Okay, I'm going to shut up. We need to get back to this. Negative b. All right, so the quadratic formula, I'll just put it over here. Who's up next? Are we done volunteering, or is it time for me to start calling? I think you've answered. You're out. We'll come back to you. So are we done volunteering? What I want to know is not the answer, but like I want to start writing the quadratic formula out here. So I want what's gonna go right there. So go ahead. We'll just start going around the room. Negative 4. Okay, so that's this. Negative b plus or minus square root. We'll just keep going around. 16. Good. Minus 4 times. Now we have two numbers here. So where are we going? Oh, you're out. You're out. Go ahead. Negative 2, so 4 times a, negative 2 here, and then 1, c. Okay, so that's that. And then all over 2 times negative 2. Okay, so we have to calculate that, right? And for the most part, I think on the test, y'all did a pretty good job on this stuff. So we've got negative 4 plus or minus square root, let's see, 16. You said 8, right? Is it plus or minus 8? Plus. It's plus 8. And then all over negative 4. So then we have to probably break the calculator out. And I did bring my calculator today. 4 plus 8 is 14. So negative 4 plus or minus the square root of, wait, did I say 14? Yeah. I did, 24. All right. So now, square root 24 on my calculator. And what we want to make sure we do here is get the decimal answer. All right? I'm getting 4.8989, something like that. I'm going to go with like 4.9. Good enough? 4.9? So this is negative 4 plus or minus 4.9, and then all over negative 4. Still good? Now we have to get those two answers. So we have to do negative 4 plus this on the calculator, figure out what that is, then divide by that. So what's that? Pardon? Oh. Is there a problem? You sure? So on the first, when I do negative 4 plus 4.9, I get 0.9. And I divide that by negative 4, I'm getting negative 0.225. That's my first answer. Everyone else getting that? And then when I do negative 4 minus 4.9, and then divide that by negative 4, I get 2.225. I just want to make sure we're all in agreement with that. Someone else got that also? Okay. All right, so those are our two X-intercepts. And we will deal with those in a second, all right? When we do our final sketch, we'll use those numbers. But we're going to move on to step 5. So step 5, we want to find the Y-intercept. And who's up? I think you're up. You haven't said anything yet, right? You did? Okay, you're not up then. You're up. Have you answered? No? So for step 5, we want the y-intercept. What do you got? It's 1, right? It's just this number by itself right here, okay? Very easy to find it. Here it is, 1. So the y-intercept is, we're going to put y equals 1. All right, we're just going to put y equals 1 because it's a y-intercept. And now it's time to do the final sketch. So the final sketch, we want to do this, and we want to, you know, show some detail. This is not that quick sketch. We want this to be pretty accurate. All right. So before I put anything on here, I would like for us to take a look at like how big this thing needs to be. So go back and look at your X-intercepts. You see one of them is negative 0.0225. The other one is 2.225. So what I'm getting at is we don't want to draw our thing where this is like 1, 2, 3. We don't want to do that, right? Because everything's going to be crammed in real small. So let's do this instead. How about we do something like 1, 2, 3. That way our x-intercept will land somewhere in here, right? And then the other direction, it's negative, but it's not very far out there, so you know, I'm just going to do -1, -2, -3. Okay, does that make sense? And then for the up and down, I should look at my y's. I have y's 1, right? What's the other y coordinate I have in this problem? What do you say? 3, where did that come from? The vertex, right? The vertex gave me a y coordinate of 3. So again, I want to make sure that I can fit everything onto my picture. It looks like if I do like, you know, 1 here, 2 here, 3 here, I should be able to fit everything on. Then -1, -2, -3. All right. So there's my graph, my xy axes. And now I start putting all the information down. So first thing I'm going to do is put my vertex. And that's going to be at 1, 3. So I go to the right 1, up 3, and there's my vertex. That was my highest point. We know it opens down, right? But we also know where it hits the x-axis. It hits at these two numbers. So let's start with this one. 2.225 is just like a little bit bigger than 2, right? So let's just go to 2, a little bit bigger. I mean, this is, I always tell my students, we're not trying to land a man on the moon here, okay? We don't have to be that accurate. That's good enough, all right? And then -0.2 is going to be just here a little bit, right? So there. And then we have a y-intercept. And the y-intercept is 1, right? So that means up 1, there we go. Now, this is the point at which I'm ready to draw it, but I think it might be worth it if you're just getting kind of comfortable with this, to imagine, you don't need to draw it, but you can if you want. We've got this axis of symmetry, right? That's not really part of our graph. But whatever we draw on this side should be a perfect reflection on the other side. So what I'm going to do is, I think I'm going to draw this side first, and I'm just really going to do like connect the dots like back in kindergarten. But I'm going to make it nice and curved. I'm not going to draw a straight line. Okay, everything has to be curved here. There are no sharp corners on a parabola. So when I draw this, I like to start up here and draw the little curve like this. Make sure I do a curve and not corner. I will take points off if you draw me a V, an upside down V. I'll take points off. All right, has to be curved. And then come down like that, and then it continues down. Here you're just free to kind of do whatever and then just draw a little arrow. All right? And you want to try and do the best you can to make it look like that on the other side. So, that, right? No. No, that, see, I don't want that. That doesn't look symmetric, does it? You laugh. I'm going to show you some of your classmates' tests. Be surprised. Okay, so that's better?
Yeah.
Okay. Again, doesn't have to be perfect, all right? There you go. That is the parabola. So there's some kind of interesting things that you can determine once you have the graph we can ask some questions. I'm not going to ask you these, but you may be asking, like, why do you want to graph a parabola to begin with, right? Let's just look at this for a second. Let's imagine we have no pictures anywhere, okay? We just have this. And I ask you this question. Is it possible to plug a number in here, okay? Can you think of a number that I can plug in here where it will spit out the number 4? Do you think that there is a number that I could find, an x, some x, that would spit out 4? What do you think? No? Why not? Oh, so you're not allowed to look at that, though. See, if you don't have the picture and you just look at that, it's very difficult to tell what the biggest value that you can ever get out of this is, right? I'm asking you, can you get 4 to come out of this? Can you get 10 to come out of this? You might think you can, but now if we allow ourselves to look at the picture, what is the biggest value that ever comes out of that function? 3, right? There is no x you can ever plug into that to get anything bigger than 3, right? So this picture actually shows you a lot of stuff. And it also says, look, you can get any negative number out of this, right? All your negatives. This goes down forever. This parabola keeps going down. So is it possible to get -3 out of this? Yes, right? It is possible. So the picture gives you a little bit more than just the function sitting there by itself. What did y'all think of that? It's a set of steps, it's a process, it's a procedure, right? You just got to kind of do example after example after example. All right, let's look at maybe another one. Let's do this one. F of x is -x squared minus 2x minus 1. Oh. Okay, first step. Where are we? Robert, I think you're up. What's our first step, Robert? It's all right if you didn't. No? Vertex second. Just, do you want to determine if it's up or down first? Okay? So, what is this one going to do? Down? What are our, Robert, what's our A, B, and C here? Let's get that down. -1, -2, -1, right? Okay, so Robert says it opens down because A is -1, which is less than 0. So again, this one opens down, right? Okay, second step. Right, you're done, right? You ready? What are we doing for the second step? Vertex? You're still out. Sorry. Vertex, so what do you want to do first? You're out. See? See, this is why I want to eliminate people, because then I'll have the same people the whole time. I want to force people to respond to me today. So, get H, and how do we calculate H? We take what? Let's do the formula first. What's the formula? -b over? Okay, and then, so what would -b? That's +2, right? Because b is -2, we're doing negative of negative, that's positive. So the opposite of what you see. And then over 2 times -1. Okay, good. And that comes out to be 2 over -2, which is -1. All right, moving around here. We get k next. Remember how to get k?
Yeah.
What do?
You just plug in the -1 into the...
Yep, -1 goes into the function. Now, we have to be extremely careful with this -1 being plugged in, all right? So let's see what this means. So take a look at this. We have negative, right, out front? We have negative, but then what are we squaring?
The negative.
The -1. So you put the -1 in parentheses and square it first. All right? You do not put these together first. Order of operations, you have to do the exponents before you do multiplication. This is multiplication, that's exponents. So we're going to do that, and then we're going to do -2, and then times -1, and then -1. It's a lot of negatives in there, right? So squaring this first, what's -1 squared? -1 times -1 is +1, but you still have a negative in front. So it's -1. So that's -1. And then what's the next number? +2, right? +2 here. And then -1, which is 0. Okay. 0. It's 0. What's the next step?
Quick sketch.
Quick sketch. So I'm going to let you do that. I'm going to let you tell me. I'm going to draw a real quick X and Y axes. Now what? So this is our vertex, right?
Yeah.
We got that from this information. So I'm going to go plot that now. -1. I don't need that. But that's where it is, right? And which way does it open? Down. Which means we only have one X-intercept, right? We have one X-intercept. Which means I do not need to do the fourth step. I don't need to go find the X-intercepts, right? Because I already know what it is. That is the X-intercept, isn't it? So don't go through the work. Does that make sense? So? You sure? Okay. So what is our next step going to be? That was step 3. What's step 4? 4 we're skipping, right? Skipping step 4, which was X-intercepts. Step 5? 5 is Y-intercept. Okay, let's see where we are. Uriel, what's our Y-intercept? Don't know? You just look at the quadratic, that number right there. Okay? So y equals -1 is our Y-intercept. And at this point, we should have enough to graph. All right? We should have enough to graph. Let's see. 6-step sketch. I'll do it right here. In terms of the x's, I only have -1, right? That's the only one I have. And then in terms of the y's, the only thing I have is -1, and then what was, 0 for this one. So I think if I go like 1, 2, -1, -2, that should cover me this way. And this way, if I go up 1, 2, and down 1, 2, that should cover me. So what do I start with? The vertex, which we already know is this. That's here. And then we're supposed to plot our X-intercepts, but that is the X-intercept. So and then we plot the Y-intercept, which is -1, which is here. And now you have to draw this thing going down. So this is, again, where that axis of symmetry kind of helps. Right? Which side of this are we going to draw first? The side with the Y-intercept, because that's the only thing I know, right? Like this side, I don't know anything about this side. All I know is that this side, I have to get from here to here. So I'm going to draw something curved looking like that. And then over here, try and just curve it out, make it look as symmetric as possible. And that's good. Make sense? I think for you, at this point, what you're going to need to do is just practice, okay? Just practice. But since we still have a little bit of time and we could do more examples, I think I think it would be worth it in a class like this to talk about where this might become something useful. All right, so we're going to do a little experiment. Anyone have a textbook with them, like a heavy book? That I can, yeah, I was going to ask you if I could drop that on the ground. I didn't want to mess it up, but it's already messed up. Right, okay. It's ready, yeah, I can tell it's rented. All right, so I have a book and a sheet of paper, all right? And I'm going to drop them to the ground. And so what I want you to do is predict which one is going to hit the ground first. All right? So just, you don't need to answer me. Just, do you have your answer in your mind of which one's going to hit the ground first? Okay, here we go. It's going to be loud. Okay, is that what you expected? Could y'all tell what happened? The book hit first? So now my question is, why did the book hit the ground first? Was that everything? What? It's heavier. And then you said what? Air resistance. Any other responses? Gravity. Well, gravity definitely made them hit the ground. But why did this one hit before this one hit? So a lot of times people will say it's because this is heavier, right? This is heavier. It's going to fall faster. Does that seem to make sense? Okay. So if you believe that, I'm not going to put you on the spot. I'm not going to ask you what you're thinking, okay? But if you think it's because it's heavier, then this, for real, this, I want to know what your response is, because you said heavier. You said heavier, right? So if you think it's because it's heavier, then if I put the piece of paper on top of the book and drop them at the same time, do you agree that the book, because it's heavier, should fall away from the paper because it's going to fall faster than the paper? Right? If you believe that it's because it's heavier, then if I drop these like this, it should go like this, and the book should hit, and then the paper will follow. Yes? Yeah? Okay? So there's no tape, right? We didn't talk about this before class. Like, that paper is not attached to this. They fell together, right? So the reason that happens is because when you drop the book is pushing the air. The air has to come around the book like this, right? And therefore the air is not having an impact on the paper. Okay, so the paper is no longer impacted by the air, so it can drop due to gravity. And so basically the whole point of that little experiment, thank you, is that when you drop an object on Earth, okay, when you're on Earth or any planet with gravity, and you drop something, two different things, they will fall at the exact same rate if you take air out. Okay? If air wasn't there, everything would fall at the same rate. But air has a larger impact on the piece of paper than it does on the book, and that is why the paper, it's like a feather, right? If you drop a feather and a hammer, the hammer is going to hit the ground first, but it has nothing to do with the weight, right? So if that's true, that everything falls at the same rate, then let's take an example here. Let's say I have this cliff, okay? You got this person standing here on the cliff, and they're going to drop a rock, all right? Let's say it's a very tall cliff. Let's say this is like a 600-foot cliff or something. If they drop a rock, that rock is going to travel a certain distance in the first second, right? So let's say they drop the rock, they start timing, and let's say after 1 second, it's there. Okay? So let's say it's traveled that far. Let's say we can measure it, whatever it is. It's traveled that far in 1 second. Okay, 1 second later, after this, is it the same distance? Does it go the same distance in another second? No, it's speeding up, isn't it? Isn't that rock speeding up? So a second later, it's actually gone a lot further in the second second. So 1 second here. Do y'all agree with that? So in the first second, it travels a certain distance, but in the second second, it's gone a lot further because it's speeding up as it goes, right? So on Earth, if every object falls at the same rate, if you take out the air, then there should be some formula that tells you how far it's fallen after a certain amount of time, right? Well, there is one.
Meters per second. It's a physics thing.
Yeah, this is a physics thing, but it's math, okay, right? So here's the formula. The formula is this. D equals negative 16 t squared plus, how do I want to do this? Vt, now I'll have to do it like that, plus d naught. Okay, that looks, so don't get freaked out by that, okay? Do not let that thing freak you out. This is what happens in physics. You start getting things like that and you're like, whoa, it's all physics stuff and it looks all crazy. It's not. It's actually, this is exactly this, okay? That's exactly the same thing. The only difference is that instead of using x, we're going to use t, okay? X, t. Instead of saying c, we're going to put d with this little 0 here. Instead of using b, we're going to put v with the little 0. And check this out. A, you don't get a choice. It's negative 16. And the reason it's negative 16 is because we are on Earth. If you're on the moon, this number changes. If you're on Jupiter, well, can't stand on Jupiter, but if you were on the moon, this number would change to a different number, but the formula would stay the same. The only thing, this is basically gravity right here, okay? And gravitational force is different on every planet. So that is the formula right there. Let me explain a couple of these letters. This is the total distance object falls after t seconds. And this is measured in feet. All right, so check that out. I'm telling you that this side, you remember the y, like the Y-Intercept and all that? The y coordinate of this thing is actually going to give you the distance that it's fallen after a certain amount of time. It's measured in feet. Negative 16 you have no control over. T is the variable, t is time, right? So I'm going to put that here. T is time in seconds. We're going to get to a problem here in a second. I just got to explain the whole formula before I do it. Okay, so t is the measurement of time in seconds. This right here, let me do that second. This right here is what we refer to as the starting height. And this is also measured in feet. So this number right here is the 600-foot cliff. Okay, so in this particular problem with the falling rock, D, we say this D sub 0, or you can say this D naught. That's the way we read that. D naught is the starting height. So that's wherever you're standing before you drop the object. So when I was here with the book, our starting height was maybe like 5 feet. So that would have been a 5. Understand? Or sorry, that would have been a 5. Okay? And then we have this right here, V naught. And this is the one that confuses students the most. So I'll try and explain what it is. I'll do it with a visual example. Let's imagine we have 2 books, like your book. Let's imagine these are 2 books. If I drop them at the same time, what's going to happen? They hit the same time, right? Okay. But what if I take this one right here, and instead of dropping it, I throw it down. So I throw it and I drop this one. What's going to happen? This one's going to get there first, right? Obvious that that would happen, okay? Or if I do it the other way, this one, instead of throwing it down, I'm going to throw it up a little bit, okay? And just let this one go. So as soon as this one leaves, as soon as that one leaves my hand, right? As soon as it leaves my hand, the only thing acting on it is gravity, right there, right? So that one took longer. This right here accounts for the throwing up or the down. So like if you shoot a bullet up into the air, you're giving it some starting, not distance, but starting what? I heard it, velocity. This is your starting velocity. So tell me, can somebody tell me what this number would be if I just drop a rock?